Imagine this for a moment. Everything around you suddenly freezes. No movement, no change, no before or after. In that frozen reality, would time still exist? We usually think of time as something fundamental, something that flows constantly, carrying the entire universe from the past into the future. Every second that ticks on a clock feels real, measurable, and unavoidable. But modern physics has been struggling with a deep and uncomfortable truth. The way we understand time might be completely wrong. Quantum mechanics treats time like something fixed and external, almost like a clock sitting outside the universe, ticking away independently while everything else evolves within it. Time, in this view, is just a background parameter that doesn't depend on what's happening inside the system. But relativity gives a completely different picture. It tells us that time is not fixed at all. It can slow down, speed up, and even stretch depending on motion and gravity. In this view, time is deeply connected to the physical world and changes along with it. The problem is, these two ideas don't fit together. One treats time as something absolute and separate, while the other treats it as flexible and part of reality itself. So physicists began to question something very deep. What if time isn't a basic part of reality at all? What if it doesn't exist on its own, but instead appears from something deeper happening underneath? However, a recent experiment takes this idea to a whole new level. Scientists built a tiny mini-universe in the lab, basically a controlled system that behaves like a simplified version of our universe, and then linked it to a separate system that acts like a clock. But what this experiment revealed was truly surprising. When they looked at the miniature universe as a whole, it showed no sense of time at all, as if time simply didn't exist for it. But when they focused inside that same universe, they saw something completely different. Time was actually emerging from within. So, what is really going on here? How can time both exist and not exist at the same time? And does this mean we've been misunderstanding the true nature of time for decades? Well, to understand this experiment, we need to first change how we think about time. Instead of imagining time as a flowing river, imagine it as something that only appears when things interact. In everyday life, we measure time using clocks. But what is a clock really doing? A clock doesn't measure time directly. It measures change, the movement of hands, the vibration of atoms, or the oscillation of light. We interpret that change as time. This leads to a powerful idea. What if time is nothing more than the measurement of change between systems? Now here is where quantum physics introduces something even deeper: entanglement. Entanglement is a strange connection between systems where they become linked in such a way that you cannot describe one without the other. Their properties are not independent. They are correlated in a very fundamental way. The key idea behind this experiment is that time does not exist independently. Instead, time emerges when one system changes relative to another system. In other words, time is not absolute. It is relational. Think of it like this. If you had only one object in the entire universe, completely isolated, with nothing else to compare it to, would it change? Even if it did, there would be no way to observe or define that change. Without comparison, without relationships, change becomes meaningless. And without change, time loses its meaning. So instead of asking, what time is it? The deeper question becomes, how is one system changing relative to another? This idea had existed in theory for decades, but testing it in reality was extremely difficult. Now, for the first time, scientists have managed to test it experimentally, and what they discovered is truly shocking. In this recent experiment, physicists created what can be thought of as a miniature universe inside a laboratory. Of course, it's not a universe in the literal sense, but it behaves like one in terms of how systems interact and evolve. What makes this setup even more unique is that the scientists deliberately removed any external measure of time from the system. There was no ticking clock, no flowing seconds, nothing that could define time from the outside. They did this intentionally because they wanted to see whether time could arise naturally from within the system itself rather than being imposed from outside. To do this, they created a tiny controlled quantum setup using two main parts. The first part of the system was a set of quantum spins. In quantum physics, a spin doesn't stay in just one state. It can exist in multiple possible states at the same time. These spins were carefully arranged to act like a clock, not by ticking in regular intervals, but by providing a sequence of distinct states that could serve as reference points to track change within the system. The second part was an oscillator, a system that naturally changes, similar to a vibrating spring or a swinging pendulum. This oscillator represented the universe, the part where change happens. Now here comes the most important step. The scientists entangled the spins and the oscillator. This means they created a deep connection between them, where each possible state of the spins was linked to a specific state of the oscillator. So instead of being separate, they became one combined system. Now, after setting up this entire system, the scientists observed something truly unusual. When they described the whole system together, without introducing time at all, and looked at it from an external point of view, like observing the miniature universe from the outside, they found something surprising. The entire system behaved as a single, complete quantum state. The spins exist in a superposition of all their possible clock states. The oscillator also exists in a superposition of all its possible configurations, and most importantly, these are perfectly correlated with each other. So instead of saying the oscillator changes over time, the system is better described as each spin state is linked to a different state of the oscillator. This means all possible moments exist together, not one after another. From the outside, when we look at the entire system as one object, we don't see any flow of time. There is no before or after. The system looks frozen, like a complete story that already exists all at once. But everything changes when we look inside the system. If we now choose the spins as a reference, like using them as a clock, and compare the oscillator to them, a sequence suddenly appears. When the spins are in one state, the oscillator looks a certain way. When the spins are in another state, the oscillator looks different. And this ordered relationship creates the appearance of evolution. To an internal observer, this looks exactly like time passing. The oscillator seems to move step by step, even though from the outside, nothing is actually evolving. And this is the most mind-bending result of this experiment. If you were part of this system, you would experience time just like we do in everyday life. But from outside the system, something completely different happens. Nothing changes. There is no evolution. It looks frozen in a single state. This creates a strange dual reality. Inside the system, time exists, and outside the system, time disappears. Both views are correct, depending on how you look at it. This is one of the deepest insights from the experiment. It suggests that time is not a universal feature of reality. Instead, it is something that emerges from the perspective of an observer who is part of the system. In simple terms, time is not something the universe has. It is something the universe does through relationships. In this view, the universe does not evolve in time. Instead, what we call evolution is just the unfolding of relationships between different parts of a timeless whole. So what does all of this really mean? At first glance, it might seem like time is just an illusion, but that doesn't mean it is not real in our experience. Time is very real to us because we are part of a system full of interactions and relationships. We constantly observe change, and that creates the flow of time we feel. But at a deeper level, the universe might not be moving from past to future at all. It might simply exist as a complete structure, where what we perceive as time is just the way we experience internal changes. This experiment does not prove that time is an illusion in the everyday sense, but it strongly suggests that time is not a fundamental building block of reality.
In 2025, a group of theorists proposed something almost sci-fi. What if time has not one but three dimensions? Just like we can move left-right, forward-backward, and up-down in space, time might also have hidden directions that are invisible to us. According to the three-dimensional time theory, time has three independent directions, typically imagined as three axes of motion similar to the spatial X, Y, and Z axes. In the X direction, you're walking forward through time. This is your normal experience of life, moving from past to future. Moving in the Y direction could mean exploring alternate possibilities, different outcomes of an event during the same time period, and the Z direction could represent internal time, such as subjective experiences, memory flow, or layers of consciousness. Imagine you're walking down a straight path in the X direction. It's like moving forward and experiencing time as we normally do. Now imagine another path that crosses this one, going sideways or in the Y direction. If you could step onto that sideways path while remaining in the same moment of regular time, you might find that things are slightly different, perhaps a different version of the same day. Moving along this perpendicular second path could allow you to explore different outcomes of that day without going backward or forward in time as we know it. The existence of those different outcomes corresponds to the second dimension of time, while the ability to shift from one outcome to another is what the third dimension of time makes possible. In this theory, there are directions in time we just don't experience. Let's call them sideways time and up-down time. We can't walk through them, but particles in the quantum world can. When a quantum particle is in a superposition, means that mysterious state where it hasn't yet decided what it is. It might actually be exploring different directions in time before settling on a definite state. Right now, this idea is still very speculative and debated. But if true, it would mean our current view of time is like seeing only a shadow of a much bigger structure. We experience only one direction of time, but there could be multiple timelines branching and weaving, like threads in a cosmic tapestry. Our single arrow of time might be just one possible direction among many.